and it consumes a power of 1000 watt. So just find its resistance, inductance and the impedance. The data, first of all, any example given to us, we just kept out, just go through whatever the data is given to that equation, like the V, that is 200 volt, then F, frequency, that is 50 hertz, then current I, that is 10 ampere, and the P, that is 1000 watt. First of all, just find out the impedance, that is Z equals to V by R. Z is nothing but it is the kind of resistance. So R equals to, by using the Ohm's law equation, R equals to V by I. Instead of R, we are just putting the Z equals to V by I, and we given that the voltage V, that is 200 volt, the current I, that is 10 ampere. So we just getting that Z equals to 20 ohm. Now the next one, that is the power, P equals to I square R. Now again, the I is 10 ampere and the R is also whatever the R is given. So we are just using that equation, P equals to I square R. Now first of all, resistance, the R equals to V by I square. By using the equation, that is P equals to I square R, you are also prefer that equation too. So by V, that is a 1000. Here the whatever the V is just defining as your watt. So instead of writing the V, we have to just making that R equals to P by I square. There is one small mistake over that equation. So P is that 1000 and I square is 10 into 10, that is a I. So we are getting that R equals to 10 ohm. Now inductive reactance, that is XL, is under root of Z square minus R square. Z, that is impedance, we just find out that 20 ohm, and R is a resistance, that is 10 ohm. So XL equals to 20 square, that is 20 into 20 minus 10 into 10. So by using the by solving that mathematical method, we are just getting the inductive reactance, that is XL equals to 17.32 ohm. That is inductive reactance. Whatever the inductor, whatever the turns per coil, that is for the coil, conducting coil. But we know that XL equals to 2 pi FL. That is the equation for inductive reactance. If you are talking about the capacitive reactance, then it becomes that XC equals to 1 by 2 pi FC. So for the inductor, L equals to XL by 2 pi F. By just making the common for the L, and all the terms are removing from the right to the left side. So L equals to XL, putting the value of XL, that is 17.32, divide by 2 into, now put the value of pi, that is 3.14, into the frequency, that is 25 hertz. So we just find out the value of L inductor, that is 110.31 millihenry. Inductor, as we all know that the value of inductance is measured in Henry. The next question, that is question 5b, that is one of the most important example, many times asked in the GTU exam. So just we kept before any another example or any other questions. An iron ring has a cross sectional of the area 400 millimeters square, and the mean diameter of that iron ring is 25 centimeter. It is wound with the 500 turns. If the value of the relative permeability is 250, relative permeability mu r, that is the two permeability mu 0 and mu r. Here we are just given that mu r. So to find out the flux set up in the ring due to the current passing through that coil, and the coil resistance is 480 ohm and the supply voltage is 250, the 5 marks. So first of all, the data is given. The area of that ring is 400 millimeters square. The ring turns, that is 500 turns. The resistance of that coil, that is 480 ohms. The voltage potential difference applied to that ring, that is 240 volt. Diameter, that is 25 centimeter, and the relative permeability, that is 250. it is a unitless. The first of all, the average length of the iron ring, that is L, length is measured in L, equals to pi into dm by using the equation pi into dm. Now put the value of pi, that is 3.14, and putting the diameter length, that is 25 centimeter. So we are just getting that L equals to 78.5 centimeter, and by changing that parameter centimeter to meter, we are just getting that L equals to 0.785 meter. Now the next one, that is current I equals to V by R by using the equation I V by I using the Ohm's law. V, that is given 240, R, that is 480 ohms, so I equals to 0.5 ampere. Reluctance, that is S, it has the property of magnetic material to oppose whatever the magnetism generated in the material. Reluctance of the iron ring, that is S, given to the equation 1 by mu 0 mu r into A. A is the area of the iron ring. So S equals to 0.785, that is the length, divided by mu 0, that is 4 pi, 4 into 3.14, that is the equation of that is the value of pi, into 10 area, whatever the area, that is 3.14 into 10 to minus 7. Now the area is 250 into 400 into 10 to minus 6. This is the data which is given to you. So by solving all this one, we are getting the reluctance, that S equals to 625 into 10 to 4 80 ampere per Weber, because flux is measured in ampere turn into by Weber. Weber is a unit of flux. Now total MMF, that is magnetomotive flux, that is given by the product of flux and the reluctance. So IN equals to, now total magnetomotive force is given by I into N, current into number of turns, equal to phi into S. I is 0.5, N is 500, flux is find out, and S is 625 into 10 to 4 ampere turn into per Weber. So by solving that, phi equals to 0.5 into 500 divided by 625 into 10 to 4, we are just getting that phi equals to 0.04 meter per meter into Weber. Now the next question, the question number 3a, derive an expression for the equivalent capacitance when the capacitors are connected in series and the parallel. This is again one of the most important question asked in many times, by starting with the series and parallel form. See, this is the figure where the capacitors are connected in parallel. When the capacitors are connected in parallel, the same sources achieve all the capacitor, or you can say that in the parallel, the voltage in each and every capacitor is getting the same source. The capacitors are C1, C2 and C3. The positive of all three capacitors, positive plates of all three capacitors are connected with each other and applied to the positive terminal of the source voltage. Same thing, the negative plates of all the capacitors are connected with each other and applied to the negative terminal of the battery. So this is called the parallel configuration of the capacitor. Voltage, that is total voltage or the source voltage, is applied to all the capacitor is same. So you can see that Vt equals to V1 equals to V2 equals to V3 up to Vn if you are connecting the n number of capacitors are parallel. But the charges are different. So the total charge, that is Qt, equals to Q1 plus Q2 plus Q3. Whatever the charges are generated for the capacitor 1, capacitor 2, capacitor 3, a summation and whatever the value we are getting is it is the total value. So Qn equals to Q1 plus Q2 plus Q3 up to Qn. The equivalent capacitance in a parallel form. See, the figure is same. C equals to Q by V, where C is the capacitance of the capacitor, Q is the charge of capacitor, and V is the source voltage. By changing that equation, like C equals to Q by V instead of Q equals to C into V. Okay. Tomorrow we will just continue that topic, that paper from that topic also. Thank you.